Namaskar and welcome to a new episode of the data playlist. And today we are going to talk about my topic of interest, that is data models. I think everyone has their own definition of data models. If I ask someone what is a data model, they will say that okay, this is an object and this object has an arrow, is connected to somewhere, kind of a constellation or something. But that is true, but there is a lot to it. So today we are going to discuss about the data models and the new trends. The underlying assumption of today's topic is that people have some knowledge about the old techniques, and so I'm not going to spend much time in discussing about the hierarchical model or entity relationship diagrams. Not there, I'm not going to discuss about that, but I'm just going to show a glimpse of all those things and then jump directly into the latest trends. So without further ado, let's begin. Data models for of the year, or what is happening in the world of data model in the year 2022. Myself Somijit Parida, and I am a data analyst from business process analyst from data engineer and project specific lead of in a logistics firm. And every day I deal with a lot of data and have to create pipelines to do some analysis, then present the analysis to the organization for them to decide and further on. Okay, first let's see what models, or what is a data model. I found a good article about it. A data model gives an idea of how the finance system will look like. For example, we have something like this in Power BI, and this is called entity relationship diagram, and something like a box disconnected to another box. So that is what we are talking about here, how the final system will look like. Doing a sketch, then starting to work with this. With the data model decided beforehand, we have some ideas about what are the primary keys, what are the child keys, what are the foreign keys, many other things. Already there are many data models, or the concepts of data models in existence. I'm not going to go into the detail, but just a glimpse. Like hierarchical model looks like this. It was the first database management model, and here this is the main table, and with this main table others are connected. Then I'm not going to detail. The link of this article will be shared in the description. Then we have the network model, which is a kind of a hierarchical model, but popular model before the relational model, because relational model is much more effective than this kind of models. There are advantages and disadvantages. Please go through it later. Entity relationship diagrams. In Power BI, or people who are using Tableau, they must have seen this in the third tab. Here are the dashboards, here are the data sets, and here is some diagram is there. This is called entity relationship diagrams, where entities are called tables. That is a form, means it's a scientific term of tables called entities, or schemas in warehouses. These are the entities, and these are connected to different other entities, and that is now called entity relationship diagrams. These entity relationship diagrams have also an inherent structure, means people have tried to make a sense out of it. There are different type of schemas. These schema diagrams, or these are the main three type of models that you can create. This is more applicable in data warehouses, but in Power BI also, I feel that these models could also be applicable, and we can design many things or make a structure out of it so that people can understand everything easily. the star schema. Star schema means, well, I will not go into the details, but this is how the star schema looks. We have fact tables and we have dimension tables. Fact tables has the primary keys, all the IDs and the main data, whereas the dimension tables have a foreign key which is connected to, like for example, customer ID is customer ID here, and it has secondary data in it. So then all the data is not in the fact tables, but the data is distributed and indexed through these IDs. Then we are connecting the IDs so that we can create master tables later or create reports later or apply the formulas easily. That is called star schema. And star schema has this type of structure. This table do not have another table connected to it. If there is another line from it, like a child key connected to another entity, then that is called snowflake schema. This is how it looks like one fact table, and this is called the star schema. And then from the star schema, if the dimension table has another connection with another entity, then it's called snowflake schema. Very easy to understand. Then we have the last one, that is the galaxy schema, where in earlier two schemas we saw fact tables, one fact table, but here we have multiple fact tables, and multiple fact tables are connected to common dimension tables. So that is how this works. Just keep this in mind, because whenever you are collecting data from different applications, just draw it, and then you can see, okay, this kind of one of the model can fit into your transformation, means during your ELT process can fit and can get data easily out of it. Okay, so that is what about entity relationship diagrams I wanted to share. Then we have different other models called relational model, and in warehouses this terminology is used more, where means almost all the warehouses have a kind of relationship diagram in there. And then we have others called object-oriented data model, which is used in Azure. In Azure, we have this kind of objects, and these objects are connected by an arrow to, means we have to drag and drop, something like this we have to do. So object-oriented models and other models called flat model, semi-structured model, etc., etc. The link of this article will be given in the description box. Please go through it. Nobody is going to take an exam of yours, but just an idea, okay, what is entity relationship diagram, what is star schema, galaxy schema, because in day-to-day works, I apply these techniques because it helps me to create the data architecture very nicely and to explain also to others effectively. And also people can copy the ideas also. If they know the model, then they can copy it to their environment or do something like that. Okay, so those I didn't want to discuss, just like a quick glance of everything. I'm also not going to discuss about like what is ELT, what is ETL. Well, ETL is an old method, that is extraction, transformation and load is an old method. ELT is the current trend, that is extraction, load and transform. For example, in Azure, you first extract the raw data, then load it into the Azure environment, then do the transformation. So this is more kind of technique that is applicable in the SaaS environments, something like that. I'm not going to discuss. I think people already have knowledge about what is a pipeline. I also believe people know what is a data warehouse, what is a data lake. Well, data lakes deals more with storing raw data, and data warehouse deals more with storing structured data, like Oracle database is a data warehouse. Okay, that was the introduction. But coming to the latest trends, the old trend was big data, like mobile phones generating GB of data each day, for each person. Transport management software, like when a driver is driving a truck, there is a system there, and with that system we can from the office track where the truck is going. That system generates every 2 minutes or 5 minutes the positional data, and those are big data. If you have 500 or 1000 trucks, then you can imagine how much data it generates per minute or per periodical intervals. So that is called big data because it's big, it's very big, but that is the thing of the past. Now the new trend is small and wide data. Okay, let's understand what that means. But okay, before that, it's a funny joke. We already know about small and wide data. We use it, and I think if the experienced data engineer who are like 2 or 3 years experience, they already are doing it since ages. But though they didn't write a research paper, though it was not published, so and the person who took advantage and published, that became a new trend or something. But this is not a new trend or not a new buzzword. This has been already there since ages. Small and wide data. Suppose, for example, in logistics industry, we get orders from the client, like going from Rotterdam to Delft or going from America to India. So that is an order. Each year we get multiple orders, like 80,000, 90,000 orders to execute, and we get paid for that. Analyzing one order is called small data, but analyzing all the orders is a big data. So if we categorize the data, for example, long trips and short trips, then in long trips, the trips which are going to UK and trips which are going to Greece. So analyzing in small chunks different categories of data, that is called small data. And wide data, okay. So I think people understood the concept of small data here. Then we can take decisions. Okay, for going to Germany, we don't have to use diesel trucks. We have to use LNG trucks because we get discounts on stations and this is more effective. The traffic tolls are less. The policies are suitable. Something like that. Okay, that is all about small data, taking effective decision with the small data for different categories of data. Now, coming about wide data. Wide data means, for example, if we are implementing an application in an organization, for example, a transport management software. Though I am working in logistics industry, so I am giving more examples with transport management software, or I am telling about all these applications. But please feel free to take any other example. Or suppose like we have transport management softwares, and when we are implementing or creating a new transport management softwares, we want to collect data. So what data needs to be collected, what data needs to be viewed in the application itself? For that, we need to go to the experienced planners, ask them, okay, what do you want to see? He will say, I want to see the truck name, truck fleet number or license number, how much fuel is there, then who is the driver driving it, what is the country of the, or what is the height of the truck, and all those metadata they want to see. Collecting all those attributes, putting or implementing those measures in the application itself, then getting those wide data from the application for effective decision making, for easily implementing a model, because a model will have y equal to mx plus zy plus c z, something like that. So all those variables if we have the data, then we can create an effective model. So wide data means lot of variables in the application, getting the data out of the application and analyzing it, taking a right decision based on that. So wide data and small data. For example, trips going to UK, the trucks which are going to UK, then what are the attributes of truck going to UK? We can make a model out of it and we can analyze what are the empty kilometers, what type of trucks are being used, what are the whether drivers have passport or not, means all those kind of things. So now the current trend is of small and wide data in order to get less confused and in order to step away from the complicated big data things where we get confused, we get lost, and we try to find a model which is not fitting to each scenario. So the new trend is small and wide data. This is one of the trend in the data model environment. Then further data trends includes new tools are coming into picture, and new tools means like Azure or cloud environment, all those kind of new tools. implementing machine learning for trend analysis, and responsible AI for more decision making. And what does it mean, responsible AI? It means, for example, the AI shouldn't have bias in it. Like, for example, if it is taking some kind of weird decision based on caste or religion uh, or height of the person or something. So these are the data trends which the big scholars are trying to achieve. Okay, then moving forward, then the last buzzword in the data trend is data mesh. But I guarantee that since ages, this concept has been used by different people. All the data engineers who have 3 to 4 years experience, they are using it. I will explain. First, let me give a example of data mesh. It's an architecture, data architecture. Let me go show a good picture. Maybe this could be, yeah, this could be helpful. Okay, or maybe data mesh architecture. Okay, maybe let's take this example, or maybe I can explain here. Data mesh. So mesh means I think people already know what a mesh means. In an organization, there are different departments. Each department creates or generates its own data. Finance will create its financial data. For example, a trip from A to B after execution, what are the invoices or how much money we collected. Operations will create its own data, like trip-related data, from where to where, from where we are going, how much time, how much fuel, then which driver is new, if there is a step in or step out, or there is a disconnect, connect or trailer, something like that. So they create their own set of data. Then quality management system, they create their own, like what are the incidents, etc., etc. Then we also have other departments like maintenance guys. They create their own set of data, like what are the expenses on maintenance, etc., etc. How much tires, or what is the wear and tear, a life of a truck or something. So they create their own set of data. All these mushrooms are there. Earlier, the data team was collecting, connecting, processing, creating reports, and all these works were done by the data team. But now the data mesh architecture is a concept which says that no, all of these departments or all of these mushrooms have to be data intelligent. They have to be data aware. They have to know what they are generating and how that data could be connected to other department data. The work of data team is only to integrate all the environments in a click. The responsibility of data structure or data quality is also of each department, but before that it was data team's responsibility. But now it's like a centralized or decentralizing the data, making data responsible for many departments. For that, and so that the work of the data team is reduced. They are more into analytics and less into data engineering, just integration. They are more into integration. So this is the whole concept of data mesh, that decentralizing the data, and then that is everyone takes the responsibility, and data team's load is less. They are more into analytics and creating models. So data mesh is a new buzzword. I think many of the organizations already took care of it, but this concept was not published specifically by anyone. So that became a new buzzword of 2022. But I believe, because I have been using the concepts before earlier, so I think for me it's not a new thing. Okay, awareness of data fabric, and I think we data fabric is also like towards. Let me see. Data fabric means all managing all the applications and integration process of different cloud environments. We already discussed this in a previous video. Like having one environment to manage all the data sources and technologies, so that integration is easy and data creating the pipelines becomes easy. So it's kind of awareness towards data fabric. So that is also one of the trend that is happening right now because of this adoption to cloud environment or migrating to cloud environments, different cloud environments, and then bringing all the cloud environments together. That is the concept of data fabric. I think we have come to an end, and my suggestion will be data hungry, guys. Keep up to date yourself and earn more. Be smart, means do smart work, not hard work. That being said, have a nice day, guys. We'll see each other in next video with a new good topic. Okay, bye bye. Have a nice day, guys.